Yes, so today I am going to discuss the maximum contiguous sum problem. Okay. Maximum contiguous sum problem is given a sequence of numbers. It may be positive number, maybe negative number. We have to find out the contiguous location with maximum sum. Okay. So this problem is not very difficult. If I take two for loops, one for loop for every position, and from that position another for loop which will compute up to the until the sum is increasing, okay, and non-negative, to find the maximum value. And with this setup of two for loop, we are going to get the order of n square complexity for the solution. Okay, but this problem is very popular and asked in many competitive exam and technical challenge round, and they demand for linear time solution. Okay, dynamic programming solution. We can go for dynamic programming solution. How can we solve dynamic in using dynamic programming? We have to write a good recursion. We have to write a good recursion and represent this problem in terms of subproblems. Okay. How we can do that? Let's put some name to this problem. Let's say MCS xn is the name of this problem. What does this xn represent? Xn, let's say this is x0 empty string, this is x1, this is x2, this is x3, this is x4, x5, x6 and x7. Okay, these are the numbers and we have this xn, so we can write this. We have to do maximization, so let's write max here. And so MCS xn is means we have to compute the maximum sum problem at the point xn. So we are let's assume that we are computing this for n equal to 7. So we are concerned about x7. How we can do that things? We can do that using this solution up to x6. Let's assume that we already know the solution up to x6 and we are adding one more value, let's say 10. So is this going to be considered inside the maximum sum or not? That depends on what is the value of previous sum, up to the previous sum. If the up to the previous sum value is negative, then adding these two value will be less than 10. Instead, if we take only this element, that will have more greater value. Okay, so for computing maximum sum, we will compute this. So we have two options. We can write this MCS xn minus 1 plus 10 and 10. Okay, if I write this in terms of n, then I have to write this xn and xn. This is my recursion. What will be the stopping condition? MCS x0 equal to 0. Okay, this is the stopping condition. So we have this recursion and we have the stopping condition. Now we can solve it. How we solve this problem? Using dynamic programming. Every time we use dynamic programming, we are not going to run this recursion and create a repeated time of same problem computation of repeated time. So what we are going to do, we will compute the memorization. So let's say this is my memory stack. Okay, this is my memory stack and we are going to compute all these values. MCS x0, this value is 0, we already know. Now we have to compute MCS x1. Now go to this recursion. MCS x1 is MCS x0 plus x1 and x1. What is this x1? X1 value is 5. MCS 0 is 0, so 0 plus 5 is 5, and here it is also 5. We can write this thing, MCS x1 equal to max of 0 plus 5 and 5, so it is going to be 5. Okay, so this value is 5. Now we will compute MCS of x2. How? Using the value of MCS of x1. That is the beauty. Okay, so let's write MCS x2 equal to max MCS x1 plus value of x2 15, so it is going to be 20. Okay, we can write here x2 equal to 20. We have to do one more thing. When we are computing these things, we have to compute the length also, from where to where this maximum contiguous sum is found. Okay, so for that, what we are doing in this recursion, every time which option is going to be selected. Let's assume we are returning 1 and 0. We have a flag. We are going to return either 1 or 0 with the solution, total value, and this option 1 or 0. So we are going to return, this was created from first option, 1 here, 1 here. Okay, now let's compute the other values. MCS x3, which is equal to max MCS x2 plus minus 3 minus 30 and minus 30. Which one is greater? 20 plus 30 minus 10. So it will be minus 10, and on which option? 1. So we are going to write here MCS x3 equal to minus 10 and 1. MCS x4, let's now compute this directly. MCS x4 equal to, next element is, we have computed up to minus 30, next element is 10. 10 plus minus 10 is 0, and if we take 10, so this is a different case, so let's write this one also. MCS x4 equal to max MCS x3 plus fourth value is 10, and we have 10. Okay, so and this value is minus 10, so minus 10 plus 10 0, and 10. Which one is maximum? Maximum is 10, so we are going to write 10, and from which option? 0th option. Okay, so we have total value 10 here with 0th option. So we are not taking the previous sum here. Okay, and this is not done by us manually, this is taken care of by recursion itself. Okay. Now similarly we can compute MCS of x5 equal to, now we have value 10, 10 plus minus 5 will be 5, and minus 5 itself will be minus 5. Okay. So 5 is bigger, let's consider 5 here. From which option? First option, adding with previous sum. Okay, so I am going to put here 1. Now let's compute MCS of x6. MCS of x6 is 40, so we are going to get 45 here, and with the adding with previous sum, MCS of x7 equal to 45 plus 10, 55, adding with previous sum, so first option. Okay, now we got this sequence. We got this sequence. If there are more number, we can continue these things. Now, what is the answer? Up to this, what is the computation? Every time we have computed the MCS value, we have called the previous recursive function from this table lookup. So that is constant time. So every computation is constant time. And how many such constant computation? N number of computation. So the total complexity of this computation is order of n. Now, how to return the answer? To return the answer, you just check this. What is the maximum value? Maximum value is 55, and which option? You check 1110. So you will start from 0. Okay. This option was written to find out the length. So starting from 0, 0, 1, 1, 1, 1 stick. This should be returned. So the number are 10, minus 5, 40 and 10. This is the maximum contiguous subsequence. Okay. So finding the maximum element is also order of n. Computing this value, so lookup of this value, this is also in the order of n. So these are not nested. This is sequential, order of n plus order of n plus order of n. So total complexity is still order of n. This same problem is solved in some other books with the name that is called Kadane algorithm. Okay, that is same. Okay, but they does not disclose the this uh, dynamic programming version behind this. But what they do, they take 4 variables maximum sum, they compute these things, and we can make it in one pass. One pass means when we are computing these things, we are also computing the maximum value and taking care of this length. For that, we have to keep track of, we have to take 4 variables. One is current length, one is maximum length, one is current sum, one is maximum sum. So if we update those 4 values in one pass, one for loop starting from 0 to n, then we can compute all these values. Okay, that is Kadane's algorithm. But the underlying theory is we have a dynamic programming recursion and we are solving this dynamic programming. Okay, so that's all.